Clouds of fire and smoke fly upward, and the rocket launches. The Delta IV Heavy is one of the most powerful rockets people have ever made. 3 massive engines burn tons of fuel, helping the spacecraft gain altitude. The 2 side boosters undock, leaving the common booster core for further ascent. When in orbit, the rocket releases its payload. This is the Parker Solar Probe, the first spacecraft to touch the Sun, and we'll follow its journey step by step. The probe was launched on August 12, 2018, and began its journey toward our star. The Sun is 93 million miles away from Earth. That's 390 times the Earth-Moon distance and 36,000 times the width of the United States from coast to coast. The particles of light that the Sun emits need 8 minutes to travel this distance. For our conventional rockets, that journey would take more than 200 days. But the Parker Solar Probe covered it faster, using gravitational maneuvers. On its way from the Earth to the Sun, the probe circled around our neighbor, Venus. All it had to do was enter the planet's gravitational field and let it attract itself. At this point, our space probe got an extra boost, and it didn't need to waste any fuel. After making one orbit, the space probe's engines changed the trajectory, and the probe left the orbit of Venus. It got enough acceleration to travel to the Sun. And on November 5, 2018, the Parker Solar Probe made its first approach to the Sun. Before touching its surface, the spacecraft had to enter the star's orbit first. To achieve this, it did even more gravitational maneuvers. Only after that did it start circling the Sun, the heaviest object in the solar system with the most powerful gravity. So, it'll give the probe an incredible amount of acceleration with each flyby. The Parker Solar Probe was constantly moving between 2 points. Those were the perihelion and aphelion. Look, here's the Sun, and here's the probe's orbit in the shape of an ellipse. The closest point to the Sun is the perihelion. The Sun was pulling the probe there at an incredible speed. At this point, the probe began to move away from the star. It still had a lot of speed and energy, but it was struggling against the gravitational force of the star. So it gradually slowed down. The point where the probe lost all its acceleration is called aphelion. The star's gravitational force won, and the probe began to move back toward the Sun, picking up speed again. The probe made several circles following a stable orbit, but then its orbit intersected with that of Venus again. Another gravitational maneuver, and after that, the Parker Solar Probe's trajectory shifted slightly, and it gained more speed. The perihelion point of its orbit was now closer to the Sun. The probe made several more circles following this new orbit. Then again, it neared Venus. Another approach to the Sun. Each encounter with Venus corrected the probe's trajectory and gradually reduced its distance from our star. In April 2021, the Parker Solar Probe finally came so close to the Sun that it touched its corona. Although the actual distance between the probe and the Sun was 5.3 million miles, that still counted as a touch. Let's look at the structure of our star by cutting it in half. This is the core of the Sun. It's about a quarter of its width. The core is 150 times as dense as water. Because of the intense pressure and high temperature, nuclear reactions occur there. Hydrogen gets converted into helium, giving off an incredible amount of heat and radiation. The next layer is the radiation zone. This is where the heat is transferred from the core to the next layers. But the photons here don't move in an outward direction. They can be directed anywhere and re-radiated many times. Scientists believe that the average time it takes a photon of light to travel from the core to the next layer of the Sun is about 10,000 to 170,000 years. Then there's the convection zone. This is what's considered to be the surface of the Sun. But it's not a solid surface. It's an ocean of hot plasma. It looks like a bee honeycomb. That's because the heated plasma rises from the lower layers, creating something like mini geysers. And while it's still hot in the middle of those geysers, their edges cool down, creating an amazing pattern on the Sun's surface. The next layers are the Sun's atmosphere. First, the photosphere. This is the layer that gives off light. And that's exactly what you see when you look at the Sun. But careful, don't do that. You need special equipment to look at our star. The photosphere is up to 250 miles thick. This is about the height at which the International Space Station moves above Earth. Then, the chromosphere, or the sphere of color. This layer of the Sun's atmosphere gives the star its reddish hue. Solar prominences appear here. Those are powerful emissions of matter leaving the surface of the sun. Their speed can reach 430 miles per second. At some point, they get caught by the star's magnetic field and pulled back. And then there's the corona, a gaseous envelope of the sun. The most powerful ejections take place there. You can see the corona during eclipses, when the moon covers the solar disk. Then you can notice some kind of glow around the star. This is the corona. It extends for millions of miles around the sun. And the Parker Solar Probe touched precisely that area. That's where solar material and radiation are still tied to the star's gravity and don't fly off into space. And all that is beyond that area is the solar wind. It's the material and radiation that managed to escape the sun's gravity and set off into space. The Parker Solar Probe surprised astronomers by providing more information about this boundary. It turns out it's not a perfect circular wall like we used to think. The boundary is broken and uneven. It looks more like a mountain range. These bumpy regions have such a shape because of the uneven flow of plasma from the surface of the sun. The larger and more powerful the flow, the farther the boundary is from the star's surface. But scientists don't know yet what exactly causes this difference. After making the flyby around the sun, the Parker Solar Probe continued its journey and started to move away from the star again. Researchers are expecting another 4 approaches in 2022. In August 2023, the probe will make a flyby around Venus. It'll gain more speed and approach the sun at a record close distance. The next Venus flyby will happen in 2024. And hopefully, the Parker Solar Probe will be able to withstand the high temperatures and radiation so close to the sun. Luckily, scientists have taken care of that. The probe has a solar shield. It's attached to the side of the probe that will face the star. It's about the size of a house window and about 4.5 inches thick. It's made of a special material that can withstand a temperature of about 2,500 degrees Fahrenheit. That's almost 6 times higher than the temperature of a regular kitchen oven. The body of the probe is made of a white material that reflects sunlight. All the scientific equipment is placed right in the center of the shadow of this shield. If the sun's rays hit the unprotected body of the probe at close range, all the equipment will be out of action in just a few tenths of a second. The Parker Solar Probe is equipped with the Electromagnetic Fields Investigation Instrument. This is a system for measuring electric and magnetic fields, radio waves, temperature, and plasma density. The Wide Field Imager for the Parker Solar Probe, or WISPER, is an optical telescope, the one that took those stunning images of the moving plasma in the sun's corona. These streamers are what you see during solar eclipses. The Solar Wind Electrons, Alphas, and Protons investigation measures protons, electrons, and helium ions. It helps scientists study solar winds. It often harms our technology. Unexpected flares on the surface of the sun can cause severe solar winds. They can burn chips and satellites orbiting Earth. Given that we have the ISS, where people work all the time, we need to know more about solar winds and how to protect ourselves from them. While the Parker Solar Probe continues its research, it's already set several world records. It's the closest to the sun human-made object. It's also the speed record holder. During its final approach to the sun, the probe reached a speed of 101 miles per second. That means it could cover the distance from New York to Los Angeles in just 24 seconds. And a trip around Earth would take about 4 minutes. A journey to the moon in such a spacecraft would only take 40 minutes. In 2025, the Parker Solar Probe will make its closest approach to the sun, reaching a speed of about 430,000 miles per hour. But even this speed is only 0.064% of the speed of light.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms. a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
And we'll start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs.
Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our sun. Can you imagine that? It's so enormous that if we could somehow replace our sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time. Yup, you heard it right. Betelgeuse is about 600 light-years away from us, so the light we see today actually left the star 600 years ago. It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink, but just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Betelgeuse is like having a front row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Betelgeuse stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shockwaves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, hey, look at this amazing spectacle. How dangerous will it be for us? Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows? Your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space. What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation, Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance. But even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system, Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw 2 of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
You are inside a huge, hot bubble. Actually, Earth is. What happens is that the Sun is in a really hot, low-density area in the Milky Way, which is surrounded by a shell of cold, neutral gas and dust. This spot is called the local bubble. You know, that's not something new to us. This idea was first proposed about 50 years ago, and the first 3D map of this zone was created in 2019. But probably since then, astronomers have gotten more and more curious about this phenomenon. After all, why does this region even exist? Thankfully, things got a lot more interesting recently when scientists decided to map the bubble again. They not only uncovered some curious details about its shape and temperature, but they also discovered the presence of a mysterious interstellar tunnel passing through it, pointing towards the Centaurus constellation. And this space tunnel could potentially link us to other worlds. Before we dive deeper into that, let's ask a really interesting question. Have we always been inside this hot, strange space bubble? Well, the answer is no.
Nope.
When our local bubble was created, the Sun was way farther from the action.
Hi.
It's important to understand that nothing in the universe stands still. Even galaxies are always moving. So it's not just Earth that orbits the Sun. The Sun is also traveling around the Milky Way. And the Milky Way itself is also moving. In fact, some scientists believe this space ballet and the Sun's journey through different parts of space in the past could have had a serious impact on Earth's climate. But what we're getting at here is that at some point, the Sun moved toward this hot bubble in the universe. And by a stroke of luck, the Sun ended up sitting almost right in the center of it. One thing you need to know about this space motion is that it takes time. A lot of time. I mean, experts believe we'll be calling this hot bubble home for the next 10, 20 million years or so. So yeah, it might be a good idea to learn everything we can about this area. And that's the main reason why more and more studies are popping up, trying to explain how this region was formed in the first place. One of the most likely explanations for this weird phenomenon is that a bunch of massive stars exploded as supernovas up to 20 million years ago. These explosions blew gas far away, creating a giant, empty, hot bubble in space. At first, scientists thought just one supernova linked to a star called Geminga in the Gemini constellation was responsible for making the bubble. But now, they think it wasn't just one explosion. Instead, several supernovas from stars known as the Pleiades moving group could be involved. Together, these explosions may have created a big, thin shell of gas and dust around this space blob, like a giant cosmic leftover. Other studies also suggest different origins for the local bubble, but they still point to supernovas. Even though it seems like there's no general agreement on its origin, scientists have figured out a lot of facts about this region, and that has to do with its shape. You see, this bubble doesn't have a perfectly round, spherical shape. It's more like a blob with a somewhat egg-shaped form. Another interesting thing about the local bubble is that it is absolutely hot, hovering at a temperature of about 1 million degrees on the Kelvin scale. To give you an idea, that's about 1,800,000 degrees Fahrenheit. So now you might be wondering, why aren't we all cooked in here, since we literally live in the middle of this hot mess, right? Well, that's because of another feature of this strange bubble. Even though the temperature is ridiculously high, the atoms are so spread out that they don't really make things heat up that much, which is great news for us on Earth. Alright, so we know a bit about the local bubble's shape and temperature, but finding out more about it while we're physically inside of it is a lot easier said than done. Imagine you're sitting in a car, trying to describe the shape of the vehicle from the driver's seat. It's hard to describe the whole car when you can only see parts of it, but with the right tools, like a rear-view mirror or a camera, it becomes much easier. And in this case, the right tool is the Rosetta, a powerful space-based X-ray telescope built by an institute in Germany. Thanks to this beauty, scientists got to explore the local bubble in way more detail than ever before. One big advantage of Rosetta is where it's located. Our planet's atmosphere actually stretches way farther into space than most people realize, with a huge cloud of hydrogen called the geocorona that extends well beyond the orbit of the Moon, reaching hundreds of thousands of kilometers into space. The Rosetta is sitting in a stable position thanks to Earth and the Sun's gravitational pull, about 930,000 miles from Earth. And because of that, this X-ray observatory is the first of its kind to observe the X-ray sky completely outside our glowing geocorona. And thanks to Rosetta, scientists found out more interesting things about the local bubble. The oddly shaped bubble isn't just sitting there, it's actually slowly growing. The area is expanding up and down along the galactic plane. And by galactic plane, I mean the flat disc-shaped region where most stars and matter in the galaxy are concentrated. So, the local bubble is growing in a perpendicular direction to the galactic plane, which makes sense because there's less stuff in the way above and below the galaxy compared to the crowded middle. The map of the local bubble also shows us an interesting temperature gradient pattern. Here you can see that the hottest parts are marked in red, while the cooler areas are in blue. Observing this temperature pattern is really interesting because, according to specialists, it fits with the supernova theory for the bubble's creation. This new 3D model of the shape of the local bubble also revealed a hidden surprise: the existence of an interstellar tunnel pointing towards Centaurus. Now, researchers are wondering if this tunnel might connect our local bubble to another nearby superbubble. And yeah, our hot space blob isn't the only one out there. The universe is full of these superbubbles. They not only trigger the formation of new stars and planets, but also influence how galaxies are shaped. By the way, one recent study suggests that the creation of the local bubble was responsible for the formation of all young stars that are close to us. So, if the theory that this newly discovered tunnel could connect to other spots in the universe is right, that would give us proof for a very popular theory proposed back in 1974. Back then, scientists suggested for the first time that there might be a hidden network of space tunnels connecting hot bubbles across the universe. We just can't see them. In the 90s, another study also suggested the existence of an interstellar pathway, which is now known as the Canis Majoris Tunnel. The research suggests there might be a space tunnel connecting our local hot bubble to the Gum Nebula, a large cloud of gas and dust more than 1,000 light-years away from Earth. But they also mention another intriguing possibility, that the Canis Majoris Tunnel could be linking us to an even more distant superbubble. Even though the idea of intergalactic tunnels connecting space bubbles is fascinating, and studies over the years have suggested it's possible, it is still really hard to prove. The truth is, we don't know where this newly discovered tunnel in our local bubble leads. But with this new finding and all the new technology helping us explore, it definitely feels like we're one step closer to finally cracking the mystery.
A large space probe is nearing the Sun. The terrifying heat of the star begins to melt the shell of the spacecraft. Another moment, and the probe bursts into flames. In no time, it disintegrates in a powerful explosion. Ah, what a sad ending. If it were true, it was not a probe. It was a comet known as 3I Atlas. And despite everything people say, it's still intact and thriving. The thing is, there is a rumor online saying that comet 3I Atlas exploded when it got closest to the Sun. But astronomers say this is not true. There was no explosion, and the comet's nucleus still looks whole and undamaged, which is kind of surprising, since comets that pass very close to the Sun usually go through some serious changes. You see, comets are made of a mix of ice, dust, and rocky material, which is why they're often called dirty snowballs. So, when they come close to the Sun, the intense heat from our star makes their ice turn into gas. This new gas can burst out in huge jets, form a cloud around the comet called a coma, and/or be pushed away into a long tail. Sunlight makes all of these parts shine more brightly, and even people with small or simple telescopes can study the comet if the viewing conditions are good. But aside from being a breathtaking view, such a close approach can break off pieces of a comet or even tear its whole nucleus apart. Now, it's true that some comets survive this process. But many, especially small ones, or comets entering the inner solar system for the first time, break into pieces or disappear completely. Well, 3I Atlas acted differently. So there. It reached its closest point to the Sun on October 29, 2025. This point is called the perihelion. At that moment, the comet was about 130 million miles from the Sun. That's about 1.5 times the distance between the Sun and our planet. The comet was also on the opposite side of the Sun from Earth, so the star was blocking it from our view and we couldn't see the comet. Anyway, even though 3I Atlas could hypothetically break apart or release lots of fragments, it didn't. The nucleus stayed intact, and this made the comet's behavior even more unusual and interesting to scientists. They looked closely at the new photos and said everything looked normal. Now, interestingly, the day before, some people thought the comet had broken into pieces after it came out from behind the far side of the Sun. This idea became popular after a blog post said the comet had lost a lot of mass. So, to make this claim, the blog used photos taken on November 9th by 2 small telescopes in Spain. The pictures show jets of gas coming out of the comet. The scientists used this to estimate how much material was coming off the comet, claiming that it should have broken into at least 16 pieces. However, many scientists have questioned this statement. Most researchers say there's no proof that the comet exploded. One scientist who studies the comet says that all the images he had seen showed a completely normal, healthy comet. There's no sign that the main body of the comet has broken apart. Still, now that the comet is coming back into view, astronomers are watching it very carefully. They want to learn more about the comet's materials and structure. Right now, if you look at it from Earth, the comet seems to be slowly moving higher in the eastern sky. If the weather is good, people in many parts of the northern hemisphere can see it with a small telescope, like this one with a 6-inch lens. And many do pay attention to the comet. Since it was discovered in July, it has become the center of many curious ideas. Some people are sure that the comet, which comes from outside our solar system and might be more than 7 billion years old, could be a probe sent by a different civilization. Now, most astronomers strongly disagree, of course. They believe the comet is completely natural and comes from another star system somewhere in the Milky Way. And this is actually exciting. Comet 3I Atlas is only the 3rd interstellar comet ever seen, and it is the largest one of its kind. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But 3I Atlas, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which was just a quarter-mile long, and Borisov, which is about 0.3 of a mile across. Plus, 3I Atlas may be the oldest comet humans have ever observed. Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. It was the first known object from another star system to pass through our solar system, basically our first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. As for 2I Borisov, it sits in between, at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma, a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it also had a long tail of dust and gas. Now, 2I Borisov is speeding away from the Sun and will never return. But it allowed scientists to take a glimpse into the chemistry and history of distant worlds. Now, let's get back to Comet 3I Atlas. It will pass closest to Earth on December 19th. Until then, scientists will make many more observations. People will also make many new claims about the comet, that's for sure. But it's best to be cautious and not believe everything immediately. By the way, even though you can't see this famous comet with your own eyes or with a regular telescope, hey, that's good news. a powerful telescope in Italy is streaming it live for free. Whoa! So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That's a big number. How about we make a few comparisons? The Eiffel Tower weighs around 10,000 tons. So, 33 billion tons is the same as 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, well, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. Now, 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, which, if you're paying attention, is where they got the nickname Atlas. Shortly after, NASA confirmed that the object wasn't from our solar system at all. Now, besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and dust. So this suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the two other known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. Hey, that will get you a speeding ticket. And unlike objects in our solar system, which follow curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. Now that the comet has moved past the Sun, telescopes on Earth can see it again. Comet 3I Atlas is important to us because it's only the third interstellar visitor we've ever seen, and it may be the biggest and oldest one yet. And it didn't break apart near the Sun like some other comets. By studying it, scientists can learn what materials exist in other star systems and better understand how comets, and even planets, form in our galaxy.
More than 1 million Earths can fit in our Sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the Sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the Sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us.
Imagine a powerful giant, like the Sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the Sun be able to withstand the intense gravitational pull of a tiny black hole, or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide, to supermassive ones that are billions of times the mass of the Sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if two or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of black hole that weighs 3 to 10 masses of our Sun, while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So, stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own Sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila, a stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So, what are the chances that such a little monster will come for our Sun? And in that case, what will happen to us? Well, actually, the likelihood of the Sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chances of the Sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole in our solar system is Gaia BH1. It's about 10 times heavier than our Sun, and even this one is about 1,600 light-years away from us, which is a quadrillion miles. So, it's safe to say that our Sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So what now? We know that the Sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So imagine if a rogue black hole arrived in our solar system and has begun to approach the Sun. As it gets closer and closer, the black hole's immense gravity will start to pull the material from the surface of the Sun. The Sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. That's kind of what would happen to it. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the Sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The Sun would become much brighter and hotter than before. The Sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans. The Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. All the planets would be destroyed. Now, the Sun being a larger object than a typical star wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the Sun's outer layers to be pulled away, creating a massive blast called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the Sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So, let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the Sun. Let's hope by that time, we will already be living on other distant planets. You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The Sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there is no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the sun, which gives us amazing sceneries. Sunspots are part of the sun's visible surface that are on average way cooler than the sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the sun's visible surface. That way, the rest of the sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the sun and place it somewhere in the night sky, it would be different, as bright as the moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the moon. It would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $1 billion. The moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth with no need to invent something. There could even be a combination of 2 elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the moon. There would be another elevator to finally lower it down to the surface of the moon. Planets in our solar system have predictable and stable orbits, but gas-giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, 2 gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom,
both planets are gone. It's different if it's not a head-on collision. If two cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic, unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems. So we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten.
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobetor. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blow-torched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface. which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun. But its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps down the road, we'll find some cool creatures on many of them.